What's going on, guys? Today we're going to talk about the Gauss-Jordan elimination method, okay? This video isn't going to necessarily talk about the Gauss-Jordan process and theory per se, but we are going to use the theory itself and all the rules that goes along with it to determine our inverse of square matrices. Okay, so this is going to be a quick summary and overview of the Gauss-Jordan elimination method, and then we're going to actually apply it to find inverse of a matrix. So there are three main rules that we deal with regarding the Gauss-Jordan elimination, right? So we could either swap the positions of two rows, we could multiply one of the rows by a non-zero scalar factor, right? And then we could also, after we multiply one of the rows with a non-zero scalar factor, we could add or subtract that initial row with any of the other rows in your matrix. Okay, so we're going to actually practice using those three rules throughout the example that I'm going to lay out next. But first, let's go through a quick overview of how we use the Gauss-Jordan elimination method to find the inverse. So there's a couple preliminary things that we should do, right? So we talked about in previous videos of determinants and what an inverse matrix is. So one of the first things we have to check is, are we dealing with a square matrix? So in other words, are we dealing with an n by n matrix? If we're not, then stop right there, because we're done. There's no way we could use the Gauss-Jordan elimination method. There's no way that we could determine the determinant, and there's no way we could find the inverse matrix of that matrix that we're given. Okay, so once we determine it's a square matrix, we're going to have to figure out what the actual discriminant is, right? If you remember what a discriminant is, it tells us whether or not we are able to find an inverse or not, and ultimately if we're able to solve the systems of equations. So if we determine that the discriminant is non-zero, then we're able to proceed and say, okay, great, let's use the Gauss-Jordan elimination method and move forward to find our inverse. Which brings us to step 3. And we come across this topic that might be very foreign for most of you. It's called the augmented matrix. Okay, don't get intimidated. That's just a fancy word for this, and I'm going to write down right now. So we're going to have this n by n matrix A, and then we're going to have a similar n by n matrix, an identity matrix called I. So the way it's set up is, this is our augmented matrix. We have our n by n matrix A here that we separate with this vertical line, and then we have the n by n identity matrix to the right of that vertical line. And that is our augmented matrix, okay? So this is, you could say, the theoretical part of it. Now, our goal is to get the A to the other side where the I is, and then ultimately get the I on the left side of the vertical line. So in other words, we are going to flip things, where the identity matrix is on the left side, and then on the right side we have A, but it's no longer A. It's actually going to be our inverse of A. Okay, so that's the whole goal here. We're going to use Gauss-Jordan elimination, maybe not elimination per se. We're going to use the Gauss-Jordan method to get from this left part to the right part here. So again, A is your n by n matrix that you want to find the inverse for. I is your identity matrix, and we're going to start with this augmented matrix where your original n by n is on the left side. The identity matrix is on the right side, and we're going to flip things. So this is analogous to, if you remember how we dealt with finding the inverse of a function. So you would flip the y and the x variables, and then you would solve for y. So in a way, you could think about this like that. So without saying much more, why don't we just jump forward and try out a practice problem. Okay, So here is our example matrix. And I should have done this. Let me call it A. Why not? So it's a matrix, and we're assigning it the variable A. It's a 3 by 3, which is something that we should be familiar with by now. So what was the first step? Well, we established that this is already a 3 by 3 matrix, which for sure it's a square matrix. Okay, so I'm just going to do this, square matrix. Check. Okay, that's one. Step 2 is determine the discriminant. So, I'm sorry, I didn't mean to say discriminant. I meant to say determinant. So, scratch that. Discriminant is for quadratic equations and finding the roots. We are dealing with matrices, so it is the determinant. Apologies for that. Well, let's figure it out. It has to be non-zero in order for us to proceed to find the inverse matrix. So let me put in the work here. So if you remember, I'm going to skip some steps and just move forward. Let me not skip steps. Plus, minus, plus. Okay. Let me copy things again. As so. So I'm going to do the first row, first column, right? Where I care about the 1. That's our multiplier. So it's a positive 1. And then I care about the things that are not crossed out. So if I remember the easy hack method, that is going to give me a negative 8 here. That's going to be a minus 20. Okay. And then I'm going to copy this. Let me do this just 2 more times. And just like that, we have 2 replicated matrices. So I'm just going to go forward here and start making some annotations. So the second one, always first row, get rid of the second column. And then finally, the third one is going to be the first row, third column. Now, remember, we're only handling the determinant here, right? So this means we care about this, and then we care about that. So here, for the second one, that is on, again, another 1, negative 3 and 4, that's a negative 12. And then negative 6 times negative 6 times 5, negative 30, but there's a negative sign, so that's plus 30. Okay, and finally this one, it's a negative 2, followed by a negative 3 times 4, again negative 12, minus negative 6 times negative 2, that's a 12, add a negative sign, negative 12. Okay, now let's do all this together. So this becomes negative 28. This becomes, let's see, that's 10, 20, that's 8. And then this is negative 24, and then we double up with a negative, so that's going to become a 48. All right, well, just looking at these numbers, if I add them all up, I could conclude that determinant of matrix A is not equal to 0. So that means that there is an inverse matrix to this. Is an inverse matrix. Great. So we got the preliminaries out of the way. Now let's get to the nitty-gritty stuff on the next slide. So now that we know that we're dealing with a square matrix and the determinant is non-zero, let's proceed with actually finding the inverse of the matrix. So in front of us, I already went ahead and put the augmented matrix. So as you can see, the left side of the vertical bar is our matrix A, our original matrix. And on the right side of the vertical bar, we have our identity matrix. Okay, so you might be asking yourself, okay, well, where should I start? In all honesty, you could start anywhere. But for this specific problem, I'm noticing already that we have a 1 here, okay, right up the top left corner. So that tells me we're already at a good start. Why? Because we are trying to get an identity matrix right here. And the identity matrix, the first coefficient, or the first number that shows up on the identity matrix, is a 1, right? So I'm going to use this as my pivot point. And my goal is to eliminate this -3 and a -6 such that we could get it closer and make it 0 and 0, one step closer to our identity matrix. So I'm going to go to the right here. Now, I'm going to use 1 as my pivot point, which means I'm going to use this whole first row, okay, to manipulate and add on to the second and third row. So because of that, I'm going to use a specific color here. I'm going to use red to denote that is the one that we're manipulating. So 1, 1, -2, vertical line here, 1, 0, 0. Looking good so far. So now that we have the first row put in, let's work on manipulating the first row to work on the second row. So remember, our goal is to get rid of this -3 and make it 0. So how do we do that? Well, we have to multiply this value, what I call a pivot point, 1 by 3, right? Because to make -3 into 0, we have to add 3. So let's multiply this whole row by 3, and then we'll add it to the second row right here. So it's very important to note that bookkeeping is your friend when it comes to dealing with these types of problems. Okay, so I'm going to use white for rows 2 and 3. So multiply 3 and 1, that gives you a 3. Add it to -3, this is a 0. Again, we have, now we're looking at the second column. So this is a 3 because it's 1 times 3. And then 3 plus -2 gives us a 3 minus 2 is a 1. With me so far? I hope so. 3 times a -2, that gives us a -6. And -6 plus 5 will give us a -1. Okay, 3 times 1 is another 3, and we're adding it to 0. So now we have a 3 here. And anything times 0 is just 0. And then we add it to 1, that remains a 1. This is a 0. We are done with row 2 for now. Let's continue on to row 3. So if you notice and remember, I highlighted -6. So that means we have to add 6 to get a 0. So let's multiply the whole first row by 6. So 1 and 6 is 6. 6 minus 6 is 0. Again, 1 and 6 is 6. 6 plus 4, that gives us a 10. Okay. 6 times -2, that gives us a -12. And -12 plus 4, that gives us a -8. 6 and 1, 6. Add it to 0. That is a 6. 0 times anything is 0. So this is 0. And then we get a 1 here. And that is our first iteration. Okay. So let's rinse and repeat. All right. Well, where do we start now? What I'm seeing is I have zeros here. What I want to do is I need to get a 0 here. And I ideally want a 0 here. But let's take a look. We have a 1 right here, which is a good point for us to use as a pivot, right? So what I'm going to do now is use row 2 as my baseline. And I'm going to multiply that by a scalar and then add it to rows 1 and 3 such that I could reach my goal. So my goal now is to eliminate 1 and eliminate 10 and make those into 0 by using row 2. So let me draw things out. Okay, so we're ready for our next phase. So I have row 2 in red already, which is going to let us know and remind us that this is the one that we're manipulating with a scale factor, and then we're going to apply it by addition to rows 1 and rows 3 separately, of course. So let's deal with row 1. So what do we have to do to get rid of 1? Well, I have to add a -1. So I'm going to multiply all the components in row 2 by -1 and add it to row 1. So this top part remains 1 because 0 and anything is 0. 1 times -1 is a -1, and then add that to 1, that's 0. -1 and -1, that's a positive 1. +1 and -2, that is going to give us a -1. Okay? And so -1 and 3, that's a -3. Add that to 1, that gives us a -2. -1 plus 0 is a -1 here. And then this remains 0. So we're done with row 1. Let's move on to row 3. So we have to get rid of a 10, which means we have to add a -10. So let's multiply row 2 now by -10 and then add it to row 3. Again, this part is 0. -10 plus 10 is 0 here. Okay? And then -1 and -10 is a +10. So you take away 8. That gives us a 2. -10 times 3, that's a -30. -30 plus 6 gives us a -24. Okay? Finally, -10 and 1, -10, -10 here, and then of course this is 1. That is complete now. And we are going to move on to the next phase, the next iteration. So let's take a look at what we have on the left side. It looks like we're almost there, right? So the only thing we have to do now is really eliminate these two things, the -1s. But you might be asking yourself, well, wait a minute. How's that possible? I have a 2 here. Don't worry, remember? We could always manipulate every single row by a scale factor. In this case, our goal is to get a 1 here, right? So what we could do is we could multiply by either 1/2 to this whole row, or we could divide by 2. Same thing, right? That way we'll get a 1 here, and everything on that row will follow suit. So let's do that. So I'm going to just write everything in white here. I'm going to focus on the third row first. 0, 0, that's a 1. This is now a -12 because I am dividing by 2. This is now a -5, and this is now a 1/2. Okay? All right. And just so I could take it step by step, let me just repeat everything here. So this is 0, 1, -1, 3, 1, 0, 1, 0, -1, -2, -1 here, and a 0. Okay, I'd say we're almost there, right? Because now we have this pivot point, and we are very close to having the identity matrix here on the left side. So let's just figure out what we have to do. Well, the beautiful thing here is these are already -1, which means we don't have to do anything to row 3, right? All we have to do is just add row 3 to both rows 1 and then row 2, such that these get nullified. So let's do that. All right. I have my last row ready to go, and I forgot to highlight these guys to remind us that's what we're trying to get rid of. Okay, so let's proceed. Let's work from the second row and then eventually to the first row. So again, we're just adding row 3 to row 2. So this becomes 0. This remains a 1. This now is 0. Okay, -12 plus 3. That gives us a, oh, let me get my pen here. That gives us a -9. Okay, negative 5 and 1, negative 4 here. 1/2 plus 0, this is a 1/2. Final step. Okay, let's add row 3 to row 1, and then we're pretty much done. So this is a 1, this is a 0, 1, negative 1, that's a 0, negative 12 plus negative 2, that's a negative 14. Negative 5 and negative 1, that's a negative 6. And 1/2 and 0, that's a 1/2. And that's it. We're at our stopping point because there is our identity matrix. We have fully transformed the identity matrix from the right side of our augmented matrix to the left side of our augmented matrix, which means everything on the right side of the vertical bar is our inverse matrix. Okay, so let me write that down. So A inverse is negative 14, negative 9, negative 12, negative 6, negative 4, negative 5, 1/2, 1/2, 1/2. Okay? So I know it seems like a long, tedious process, but really it's a step-by-step procedure that is just a repeat of the same thing, right? And like I said before, it's all about the bookkeeping. So if you're good about the bookkeeping, you shouldn't have any problems. Just remember the basics and you should be fine. All right? I'll try to make another example problem and work through that to help guide you guys more. But for now, that's it. So have fun and good luck.